Is it really true that the Earth rotates? And if the answer is yes, then how come that as I am in the studio now that you are watching me on the screen, you don't see me rotating, or so you don't see the screen rotating as in going round for you to see? This is a very, bigger question that most people have been asking. But of course, as I take you through, gradually, you really appreciate the fact that the Earth rotates. Is that okay? But before that, let me say a very big thank you to Madam Janet Okwa of Mase in the Ashanti region, Kumasi, popularly known as Eno Ama. Thank you so much for being supportive. I really appreciate all your efforts. Now, let's go to our objectives. Okay? By the time we are done with this particular presentation or lesson, what do we intend getting? And in fact, we've had questions. WASI questions on rotation. Okay? And so the objective, or say objectives, number one, we have, we should be able to define rotation of the Earth. Is that okay? We should be able to define rotation of the Earth. Then the second one, to state the effects of rotation of the Earth. If the Earth indeed rotates, what are some of the effects does this rotation bring? Is that okay? We shall look at that one. Then also explain the effects of rotation of the Earth. Once we are able to state these effects, we should be able to explain the effects one after the other. Is that okay? Good. Then use a suitable diagram to explain day and night. Is that okay? Good. And so, even as the focus is on rotation, if we happen to get more time, then we shall look at an aspect of revolution as well. Because rotation and revolution are just like what? Twins. Whenever you hear of rotation, then you may hear of revolution as well. Is that okay? So these are going to be our objectives. And I believe by the time we are done, of course, you'll be able to achieve all these objectives, even as they keep asking questions on rotation and revolution as far as WASI is concerned. Now, the Earth experiences two different movements. And these movements are, number one, we have rotation. And number two, we have revolution. And in fact, the Earth has been rotating billions of years ago. It has never stopped. It keeps rotating. And if nature does not stop it, then of course it will continue to rotate in about, other billions of years to come. Is that okay? And so I know the question that one may ask is that if the Earth has been rotating, then what if one day it keeps rotating? What will happen? In fact, if it stops rotating, there will be a catastrophe. Is that okay? On the surface of the Earth. So even as we go, I'll use the very vehicles that we have been boarding to our various destinations as examples for you to really understand. Is that okay? All right. So rotation in general, okay, refers to an object spinning motion about its own axis. Rotation in general refers to an object spinning motion about its own axis. When we talk of the axis here, what are we talking about? Are we talking of the y-axis? and then the x-axis. All right. Now, what then is Earth rotation? Okay? And Earth rotation refers to the movement or the spinning of the Earth around its own axis. The movement or the spinning of the Earth around its own axis. Is that okay? So the time it takes for a planet, don't forget that the Earth that we are talking about, of course, is a planet. Because in our previous revision show, I remember talking extensively or sort of giving much explanation on the Earth. Okay? So the time it takes for a planet or other celestial object to complete one spin around its axis is called its rotation period. I believe you are taking note, because even as we move along, my producer will give you the opportunity to answer certain questions. And so even as I underline them, you must as well take note of them. Is that okay? Now, the rate of Earth's rotation is expressed in degrees. Don't forget about that one too. Okay? Good. Let's move ahead and see whether we will meet the axis or sort of get to know the meaning of the axis. Is that okay? All right. So we are talking of the movement of the Earth around its own axis. Good. Now, I have with me here a blank page. Is that okay? So I will draw my Earth. Don't forget that the Earth is spherical. In other words, oblate or spheroid or a geoid. Is that okay? And so, if I have my Earth like this here, then I can have my day and night. So I can use to shade this part to form my night. Is that okay? And then this blank part becomes my day. But then, what is the axis are we talking about? I can have my axis here to be like this. Okay? Then I label here N, which stands for north, or say the North Pole. Then here S, standing for the South Pole. Is that okay? Good. Then I may have my sun here. Is that okay? Shining. Of course, the sun should be bigger than the Earth. Is that okay? So let me just use sun here. Let's say something like this. Then I have my sun shining. Is that okay? So this North and South Pole, this particular line is what I mean by axis. But the point is, do we really have this line through the Earth? Okay? The answer is what? Is no. This line that we are talking about is an imaginary line. Physically, you will not see it on the surface of the Earth or in the middle of the Earth, but it's an imaginary line around which the Earth spins. And so if that is the case, you will actually see that the Earth is tilted by this particular angle. And this angle is 23.5 degrees. Is that okay? And I'll throw more light on this particular angle. All right. Now, a period of 1 full turn or 1 full rotation is 360 degrees. And I believe that one you are aware. In mathematics, you see a complete circle sums up to 360 degrees. So when the Earth makes a complete turn, in other words, when it completes its spin, it's adds up to, or sort of, it makes 360 degrees. and it takes the Earth 24 hours to complete its spin. Is that okay? With respect to the sun, called solar day, and 23 hours, 56 minutes, and 4 seconds with respect to distant stars, called sidereal day or period. And I believe during our senior high school hour, I took my time to explain. So this one too, you don't have much problem about this. Now, this indicates that the rates of rotation of about 15 degrees an hour, or a degree in 4 minutes. Is that okay? That is, if it takes the Earth 24 hours to make a complete turn, or to complete its spin, one spin, okay, then if that is the case, then it will take the Earth every 1 hour to make an angle of what, 15 degrees. In the same way, you take it 4 minutes to make an angle. And when it comes to this 15 degrees and a degree, as in degrees, yes, as in expressed in degrees, and then we also having it in minutes, an hour, and then 4 minutes respectively. In fact, we really use this when it comes to calculation of local time using the longitudes. Is that okay? Now, don't forget, let me chip in this before it escapes me. Don't forget that the Earth, when we are talking about these two main different movements of the Earth, or the two different movements that the Earth experiences, which is the rotation and then the revolution, the speed at which the Earth revolves around the sun is faster than that of it spinning on its axis. Is that okay? Take note of this. When it comes to the revolution, or as in the Earth revolving around the sun, it takes it, or sort of it covers a distance of 107,000 kilometers per hour, meaning within an hour, the Earth revolves around the sun for about 107,000 kilometers, which is equivalent to 67,000 miles. But when it comes to its speed in spinning, is that okay? That one, it is 1,000 miles, which is equivalent to 1,600 kilometers per hour. And the other time when I was explaining, when it comes to Ghana, on our highways, some of the rules given to these drivers, the fastest that you can go, okay, so that you don't cause accidents on our roads, is to drive 120 kilometers per hour. And this one, we are talking of 107,000 kilometers when it comes to the revolution, and 1,600 kilometers when it comes to it spinning. So then the point is, if the Earth can spin at this speed, and it can also revolve around the sun at this speed, how come that you and I on the surface of the Earth, we don't feel these two movements? Is that okay? And I believe when you visited our social media handles, the question of the day was put right there. So as we move along, we'll get to know that one too. Now, the speed of rotation is 0 at the poles, but about 1,600 kilometers per hour at the equator. Is that okay? So it means if you are at the poles, more or less, you will not feel the speed. But as latitudes decrease, that is when you feel the speed. Is that okay? So don't forget that at the equator, that is where the actual speed of the Earth is felt. Is that okay? Good. Now, this means that the speed of Earth's rotation varies with latitudes. Take note of this. The speed of Earth's rotation varies with what? Latitudes. And so as the latitudes change, the speed of the Earth's rotation also what? Changes. Just as I said that at the equator, we really feel the speed. But as you move towards the poles, then the speed of the Earth's rotation what? Keeps decreasing, or say reducing, I must say. If the Earth makes a complete turn in approximately 24 hours, which make a day, then can it be concluded that all places on Earth experience 12 hours of darkness each day? There's a question thrown to us. Of course, we are saying that the Earth takes, or say it takes it 24 hours to make a complete turn. Is that okay? And previously, we learned that the shape of the Earth has not been flat, or it is not what flat, but it's what is a geoid, even as I drew not too long ago on your screen for you to see. Is that okay? So now, does that mean that if it takes the Earth 24 hours to make a complete turn, then at a point in time, half of the Earth experiences darkness, as in 12 hours, and then another half also experiences what? 12 hours. Let's say at all places. That should be the question. So then can it be concluded that all places on Earth experience 12 hours of darkness each day? The answer is no. It is not all the days that all places experience 12 hours darkness and 12 hours what? Daylight. No, this is because during certain times of the year, we have more hours of daylight than at other times. And so what causes this? How come that at certain times of the year, we have more daylight than darkness? Is that okay? Then you may experience, oh, as for this time around, it takes quite a long time for darkness to fall, or sort of to come. Is that okay? And when you sleep, very soon then it is daytime. Sometimes you sleep and then it appears daytime doesn't want to come. Is that okay? I believe you have been experiencing some of these things. Okay, good. Now, this happens due to the fact that the Earth's axis is not at right angle with the sun. Can you see that? I do something for you to get some points from there. When I drew the Earth, and then I indicated the axis. Okay, so this happens due to the fact that the Earth's axis is not at right angle with the sun. So it is the axis that is contributing to this what? Factor. All because the axis is what? It's not straight. It's not right. It's not what? At exactly 90 degrees. Is that okay? But then it is tilted slightly at an angle of 23.5 degrees. You know, I did indicate that angle, and I told you that I'll throw more light on that. And here we are. Now, back to the axis. When we talk of the axis, we are saying it is the invisible or the imaginary straight line around which the Earth what? Spins. You can't see, okay? But we do know in our minds that we have we have a line, and of course it's an imaginary line, and it's a straight one passing through the center of the Earth. Is that okay? And then the ends of the axis are the North Pole and the South Pole, which refer to the point where the axis meets the planet's what? Surface. So when we talk of the planet here, we are talking of the Earth. Is that okay? So now let's see. Right. So if we have the Earth here, is that okay? If this is the Earth, as you can see. Right. This axis, that is the imaginary straight line, is not straight, as in it's not right angle to the sun, okay? But then it is tilted towards the sun. And so here You see, we see the arrow here, Earth's rotation on Earth's what axis. And so the arrow here is telling you that the Earth rotates from the west to the what to the east in an anti-clockwise what direction. Don't forget about that. Because when we take all the 8 planets, we have only 2 planets that rotate in a clockwise direction. That is Venus and Uranus. Is that okay? Venus and Uranus. Apart from these 2 planets, all the other planets, the remaining 6, including our Earth, they move in an anti-clockwise direction. That is a prograde direction. Is that okay? Good. And so we have the Earth's axis. Then this is the equator. Of course, the equator is the major latitude that we know. Okay? That is the latitude 0 degree. Okay? Good. So more light on the axis, you can now see it well for yourself. Is that okay? So we have this entire Earth, and then we have the axis here, and you can see it is not straight, as in right angle. Okay? It doesn't form a 90 degrees by facing the sun, but then it is what is tilted. And so if we can trace it this way, okay, then this angle that we have here, that is in the northern hemisphere, in the southern hemisphere here, that's a 23.5 what degrees. Is that okay? Good. Good. So now we have another image here. In fact, all these are Google images. All these are Google images. And so if we have our Earth here once again, we have the night here, then we have day here. Okay? But then this is the axis, the Earth's axis, which is tilted towards the sun at 23.5 degrees. So this is the sun. You can see the arrow here. And so when you check here, you see that ideally, like half of the Earth, whereby the axis is dividing, should receive the sunlight, as in the whole of this part too, receiving the sunlight together with this part. But then, because it has tilted, we have a section of this part, as in this part, okay? And this is the section that I'm talking about, where it is deepened to indicate that it is a darker portion, okay? So we have this part experiencing darkness. And then the other part that is supposed to be in darkness is experiencing what? Daylight. Why is this so? Have you seen that? And so we have this, the sun here, the arrow here indicating. So once the Earth is tilted towards the sun and the sun keeps shining, it means that this northern part has now, or say it's now facing the sun. And then the southern part, as in the southern hemisphere, is running, or say moving away from the sun. And so especially when we get to the revolution, the effects of revolution, we'll talk more about that. Now, so as a result of the tilt of Earth's axis, the amount of daylight varies throughout the year. So remember we asked a question, then we said no. All places don't receive 12 hours darkness and 12 hours daylight each day. No. All because the axis of the Earth is what? It's tilted. And so this throwing more light on that. The amount of daylight varies throughout the year. So we don't have the same daylight throughout the year. And we don't have the same night length throughout the year. But then they vary. But of course, at certain times, we have equal daylight and equal what? Night. Okay? We shall get there as well. So the least amount of variation occurs at the equator, while the most amount of variation occurs at the poles. What is the meaning of this statement? What we are trying to say is that when it comes to the variation in the night, length of night, and say length of day, okay, those at the equator don't really experience it. Sorry. And so when we take Ghana, for instance, Ghana, we are close to the equator. Okay, just about 4 degrees, 5 degrees interval from the southernmost part of Ghana to the equator. Is that okay? And so we don't really experience this longer day and shorter night, all because at any point in time, the equator receives a high amount of sunlight. But then, as in those who are closer to the poles, they really experience it. So let me go back to the slide that I showed you. Okay, so assuming that we are somewhere here, or say Kofi is here, okay, you realize that anytime that the sun shines, Kofi experiences daylight throughout, sort of. Is that okay? But those who are at the poles, if someone was here, okay, let's say Amma is here, okay, and supposed to experience darkness. Now Amma is experiencing what? Daylight. Is that okay? So when we talk of the variations in terms of the length of day and length of night, it is really those at the poles, countries located at the poles, they really experience this particular situation that I am talking about. Okay, so let's keep making progress. Now, I did tell you that the Earth moves in an anti-clockwise direction from west to east. So this is an animation from Google to deepen your understanding of the Earth rotation. Is that okay? Good. So that's just by the way. Now, it must be noted that the Earth rotates eastward. That is from west to east, as I showed you. So let's go back. Can you see that? From the west to the east, it rotates eastward from west to the east. Good. So it rotates eastward. In other words, the Earth rotates from west to east, or rotates in an anti-clockwise direction. Okay? Now, when viewed above the North Pole, that is, if an observer is at the North Pole, okay, the Earth rotates counterclockwise from west to east, just as I showed you. And this is called retrograde rotation. Is that okay? When it is when the planet is moving in an anti-clockwise direction, or say in a counterclockwise, okay, then the term for it is what? Retrograde rotation. Retrograde. Is that okay? Good. Now, due to this direction, we see the sun rising every day in the east. Is that okay? The sun rising every day in the east. So just like you are moving from the west, okay? So from the west, then you meet the sun in the east and setting in the west. On the other hand, if a planet spins in a clockwise direction, just like Venus, it is said to have a retrograde rotation. So take note, we have prograde and we have what? Retrograde. Prograde is anti-clockwise and retrograde is what? Is clockwise. Good. Now, here is very, very important. Why am I saying this? Because examiners normally set questions on the effects of Earth rotation, or say effect of rotation of the Earth. If the Earth keeps rotating, what are some of the effects does it bring? Is that okay? So one, we can talk of day and night. Of course, the Earth is oblate spheroid. The Earth is a geoid. It doesn't have a flat surface. It is not flat. It is almost what? Circular. So if it is almost circular, and then this figure, if I say figures in this shape, as in the oblate spheroid, is facing the sun. then of course you can't expect that every part of the earth will receive the sunlight. It is only a portion of it that will receive the sunlight. Is that okay? But then, because it keeps spinning, is that okay? At certain times, we have half of it facing the sun, and half of it also experiencing darkness. And then, as it spins, this dark portions gradually also feature in the sun's rays, or say in the sunlight. Is that okay? And so it shares it equally. Is that okay? If today I'm facing the sun, then as the earth spins, as it rotates, then gradually I'll be moving away from the sun for those who were in darkness to also come and experience the sunlight. Is that okay? And so one major effect of rotation of the earth is what? Is day and night. It is the rotation of the earth that brings about day and night. So please don't forget this. Then also, it gives a difference of 1 hour between two meridians of 15 degrees apart. Is that okay? We did establish that the earth makes a complete turn, summing up to 360 degrees, and it takes its 24 hours. So if 24 hours, then it means that it will take the earth 1 hour to be able to make an angle, so make a turn of 15 degrees. Is that okay? And so these 15 degrees apart that we've been using to calculate local time, okay, it is brought about as a result of the rotation of the earth. And so when it is time to explain it, I will try and do some calculation of time for you to get it well. You know, in the objectives, we said we should be able to state the effects of rotation of the earth. Then after we have stated them, then we explain all these effects. And so that is exactly what we are doing. So please, in case you enter the examination hall and this question drops, please don't give it a chance. Do your best to answer it and answer it well. Day and night is number one. Of course, it doesn't necessarily mean that at all costs it has to be the first point. But of course, it's one of the major effects. Okay. Then also the fact that it gives a difference of 1 hour, as in the rotation of the earth, gives a difference of 1 hour between two meridians of 15 degrees apart. And when we talk of meridians, you understand, it's the same as what? The longitudes. That is great. Now, the third effect is that rotation causes daily rising and falling of the sea level, called tides. Okay? During the senior high school, when we were looking at ocean current, which is a Form 2 topic, okay, I did stress that when it comes to the rise and the fall, as in the vertical movement, the ups and down movement of the ocean, it is mainly caused by the gravitational pull of the moon and the sun. Is that okay? Good. But then here, we are also getting a clue that rotation of the earth also plays what? A role. Is that okay? It also contributes to the vertical movement of the ocean water, or say ocean current. Is that okay? So it causes daily rising and falling of the sea level. So at certain times, you visit the sea, okay? That is as if there's a shark deep down there that is trying to come out, and for that matter, we have a volume of water coming up. No, it's as a result of rotation of the earth, or any of the causes like the gravitational pull of the moon and that of the sun. All right. So we still have some effects. Effect number 4. Rotation deflects moving objects such as winds and ocean currents to the right in the northern hemisphere and to the left in the southern what hemisphere. And when we talk of deflection, I believe you understand it. Is that okay? Good. Then, effect number 5, we have dawn and twilight. Please be careful you don't say tree light. As in the tree language, the Ghanaian language, seeing light. We've all the time be seeing light of day. Okay? So we have dawn and twilight. These two scenarios, or say events, are also caused by rotation of the Earth. Yeah, these two occurrences are caused by rotation of the Earth. So, in effect, we have about 5 of the effects of Earth rotation. So, let's take them one after the other, and then we explain, because what if it should drop, okay? And I keep telling you that depending on the marks against the questions, okay? If sometimes we sort of get confused when we say outline, does that mean that we should just state and then go away? And when we, of course, when they say state and explain, that one we are very much clear about that, state and explain. But sometimes it's not done, it's not stated that way. See, outline, give. When we say give, does that mean that we are going to state and explain, or just state and then leave it right there? Okay? So, I keep telling you that always check the mark, or say the marks allocation. Okay? If there's the question that give 3 effects of rotation of the Earth, and then we have about 9 marks against it, please don't just state the effects and then run away. Okay? Because it could be that when you state, you get a mark, and then when you explain, you get about 2 marks. And so if 3, then 3 by 3 is what? It's 9. But assuming you are asked to give 3 effects of rotation of the Earth, then you see just 3 marks there. Then the probability that you just have to state and go is very, very high. So please be checking all these. If not, you can have the knowledge all right. You can answer the questions all right. But you not understanding the question well can also, deny you of some salient points, or say marks. So we need to be very careful about that. Is that okay? So now, let's look at the day and night as one of the effects of Earth rotation. So as the Earth spins on its axis, only half of it faces the sun. I've told you that one already. Okay? At any given time. So at any given time, it is only half of the Earth that faces what? The sun. Then the side of the Earth facing the sun experiences daylight, whilst the other end away from the sun experiences what? Darkness. And so just like in Ghana here, if you are watching me, you know, it's around, say, if we should check the time, 8:25 or say 8:30. Is that okay? Or something. Is that okay? Now we are experiencing darkness here. Whilst we are experiencing darkness here, the direct opposite of those on the surface of the Earth, or surface of the Earth, sorry. So those who are actually at the direct opposite of us here are now experiencing what? Daytime. So it's like dawn has come to pass and then daytime. So we can take countries, especially countries around the longitude 180 degrees. Okay, don't forget that Ghana is on a longitude 0 degree. Is that okay? Which that's the Greenwich meridian, which passes through Bungurugu Yoyo. Is that okay? Somenya, then through Ghana. Is that okay? So whilst we are experiencing darkness here, those directly opposite us experiencing what? Daylight. So we can talk of places like Russia and all that, New Zealand and all that. Is that okay? Around the 180 degrees. When it's time for calculation of time, I believe that you guys will really appreciate the lesson. Okay? But of course, the focus now is on the rotation of the Earth. And probably, if we have more time, we'll look at the revolution as well. Now, so just check this on your screen. Okay? This is another animation from Google. Is that okay? So you can see that the Earth is moving from west to east. So where you see the white, is that okay? So you see the continent, Africa has come, then you see the light there. That is where, or say the portions of the Earth that experience what? Sunlight, okay? So once this portion experiences sunlight, it means the direct opposite, okay, those who are behind experience what? Darkness. And this process continues. The Earth keeps what? Spinning. Is that okay? It keeps rotating. Is that okay? And non-stop. So I don't know when, as I said, nature will let the Earth what? Stop rotating. That one, I don't know what will happen. Then you can imagine. All right. So if you want to throw more light on your day and night after you have explained, come out with a diagram. Okay. So first of all, draw your almost circular shape Earth. Is that okay? We have it here, as you can see. And then you divide it into two equal halves. Okay. One side being night and one side being what? Day. Is that okay? Then your axis, okay, as in the imaginary line around which the Earth what? Spins. Don't forget that doesn't form 90 degrees facing the sun. No, but then it is what? Tilted about 23 and half what? Degrees. And so we have the night here, and then we have what? The day time here. So you are telling the examiner that at any given point in time, we have half of the Earth receiving sunlight and the other half experiencing what? Darkness. And as you indicate the arrow to, it means the process continues unabated. It doesn't stop. It keeps rotating from west to what? To east. And so this is about day and what? Night. Then you write your day, write your night here, then this entire Earth. In fact, ideally, you should bring the Earth here. You write it below. Whenever you are labeling, or say you are naming a diagram, ideally you bring the name below the diagram. But if you are dealing with a table, then the title must be at the top. I keep telling you this. And then don't forget your sun. Is that okay? So the sun word shining. Is that okay? Good. So once you explain the day and night, and then you have this diagram supporting the expressions that you have made, of course, you are good to go. If it is 5 marks, you score all. If it is 3, you are rest assured. Okay. So, meaning that we are done with the day and night as one of the effects of earthward rotation. Now, let's look at differences in time from one place to another at different longitudes. And so, as Earth rotates on its axis, it moves about 15 degrees every 60 minutes. Please don't get confused. When we say 60 minutes here, it is the same as what? 1 hour. You see, when I kept saying 1 hour, and I don't remember mentioning 60 minutes. Don't get confused, the same thing. Implying a difference of 1 hour. And you see that between two longitudes of 15 degrees apart and 2 hours between 30 degrees apart and so on. Is that okay? An example is Rwanda on the 30th meridian, what is 2 hours ahead of what? Ahead of Ghana. Is that okay? So when you take Rwanda, for instance, Rwanda is located on longitude 30 degrees. And so if 30 degrees, and assuming we're going to have a football match, okay, and according to Rwanda's time, they are going to play the match at, say, 6 p.m. There's a match between Rwanda and Ghana, and we want to watch 6 p.m. according to the time of Rwanda. Then you are in Ghana here, and you are waiting for it to be sort of 6 p.m. before you watch. In fact, you'll be disappointed, because Rwanda is 2 hours ahead of us. So what do you think will be the time that you are supposed to watch? If 2 hours ahead of us, then of course you must watch your own. If it is 6 p.m., you must start watching the ball, or say the match at 4 p.m. Is that okay? That is good. Now, meaning we are done with the 15 degrees apart. Is that okay? So just as I explained. Now, let's take, when we take Ghana, for instance, Ghana and Nigeria. Nigeria is located on longitude, 15 degrees. So Nigeria is always 1 hour ahead of us. So when you move eastwards, you gain time. But when you move westwards, you lose you lose time. And I believe you know this already. Now, we also have the daily rising and falling of the sea level, as I explained to you. And although tides are mainly caused by the gravitational pull of the moon and sun, and I know someone will ask, hey, how come? Just look at the distance between the earth and the sun. Is that okay? When we take that of the earth and the sun, about 48.8 million kilometers. Is that okay? So how come the gravity of the sun, the gravitational pull of the sun, is able to have effect on the water body? It's having effect. But of course, you know, the moon is the Earth's satellite. So the moon is closer to the Earth than the sun. And so the moon is having a greater impact on the water body as far as its gravity is concerned. But here too, we are indicating the fact that it's not only the gravitational pull of the moon and the sun that cause the tides, but also we have rotation of the earth also causing tides. So rotation of the earth also plays a role in the periodic rise and fall of the sea level called tides. If you want to know the difference between tides, current, waves, and then all that, don't forget or say, don't be lazy not to watch the ocean currents on the senior high school hour right here on Joy Learning. Okay. Now, we also have the deflection of all free moving objects like the winds and ocean currents over the Earth's surface. Okay? The Earth moves and everything on the surface of the Earth also moves. Is that okay? And here we are seeing that free moving objects like winds and ocean current over the Earth's surface are being deflected. If they are being deflected, where do they go? So the rotation of planet Earth produces a force on all bodies moving relative to the Earth. Is that okay? As the Earth rotates, all bodies that are rotating relative to the Earth, we have a particular force that is being produced on these bodies. And the name of that force is what we call Coriolis force. So this force is known as Coriolis force, and it is greatest at the poles and least at the equator because of the sphericity of the Earth. So it is the Coriolis force that is responsible for the deflection of the ocean currents and winds. And then when we're looking at the ocean currents, I even made mention of an ocean gyre. Okay? I believe you have not forgotten about that one. Now, the direction of winds, and ocean currents are deflected due to the Coriolis effect, where the water moves to the right in the northern hemisphere and to the left in the southern hemisphere during earthward rotation. So this movement of the water is caused by the rotation of the earth. Is that okay? Now, very soon we'll be going for a break. Let's also look at probably the last effect of rotation of the earth. Is that okay? We have what we call dawn and twilight. Then we're saying the brief period between sunlight and daylight is what is known as dawn. The brief period between sunlight and daylight. Some of you be sleeping and it's like, oh, it is daytime, you need to wake up, go and bath and go to school and all that. So that brief period between sunlight and daylight is what is known as what? Dawn. Whereas twilight is the brief period between sunset and complete darkness. Before we experience complete darkness, okay, you see it's as if the sun is setting. Then you see the sun's rays appear to be sort of horizontal, as in getting to the horizon. Is that okay? So that's period between the sunset and complete darkness is what we mean by what? A twilight. And these are as a result of Earth rotation. That is when the Earth receives diffused or reflected light on the sun while it is still below the horizon. Is that okay? So on this note, let's go for a quick break. And when we come, we continue.
Are you in class 4, 5, or 6? It is now your turn to have a bite of the Joy Learning Cherry. Get ready for our all-new upper primary lessons here on Basic Classroom.
As I mentioned, my objects, you check to find if you have that same object.
We promise an exciting and interactive TV classroom experience.
We have the STEM,
television,
a computer monitor.
With our proficient and intellectual TV teachers, no problems will be left unsolved.
The 4 that we have at the end will be represented on the ones.
We will take our time and take you through the curricula from beginning till end.
We look at a very useful
Joy Learning TV lessons.
Come on, grab your remote and tune in to Joy Learning channel on Multi TV and subscribe to our YouTube channel at Joy Learning TV. Basic Classroom shows Monday to Friday at 4:30 p.m. with a repeat at 6 a.m. Joy Learning, keep learning.
Hello kids! The time to prove that you're the best and biggest kid chef in Ghana and beyond is here again. Join season 2 of the Big Chef reality show on Joy Prime to exhibit your culinary skills and win amazing prizes. Enter auditions by recording yourself cooking your best dish and send us the video on WhatsApp 055 15 75757. Remember, the deadline for submission is the 10th of July 2022. We can't wait to see the amazing talents this season brings. It's the second edition of the Big Chef reality show. So hurry, get busy, get cooking. Big Chef, good meals by kids. Big Chef, this July on Joy Prime.
News is better served when they are captured by the right lenses and aired on the most appropriate channels. We first came to you as Campus 360, but we are now Edu News 360 because we have evolved to become better and bigger, bringing you once a week educational news on Ghana's first educational channel, Joy Learning. Education helps us get exposure to new ideas and concepts that we can use to appreciate and improve the world around us and the world within us.
As a science student, I never relaxed, but I actually decided to cross and extend my boundaries.
We have explored many campuses, and indeed, many achievers have been celebrated. And it is time we delve deeper into more educational stories and project the success stories in the various schools. We will continue to capture and serve you stories from academics, sports, entertainment, and culture. Just know that Campus 360 is now Edu News 360. Let's journey through various schools and educational related events as we update you on happenings in our educational sector and celebrate the success stories and achievements on your favorite educational TV channel, Joy Learning. Edu News 360 shows every Saturday at 10 a.m. on Joy Learning.
Season is here again. In the major cities of Ghana, flooding has become the key source of human vulnerability, and varied attributions have been given to its frequent occurrences. Dear learners, it's time to show off your writing skills on the Joy Learning Essay Club contest. In not less than 300 words, write on the topic, what can be done to prevent perennial flooding in Ghana's major cities? Your essays must have your full name, your age, your contact, and your school's name. Send a copy of your essays to Facebook at Joy Learning TV, you can also email to joylearningtv@myjoyonline.com or drop off at the front desk of Multi TV office. The best 10 essays qualified to be part of the finalists of this educative contest, and there are so much Joy Learning branded items to be won. Not forgetting the opportunity to become a Joy Learning ambassador for 2022. Remember, the topic is what can be done to prevent perennial flooding in Ghana's major cities, and the deadline for submission is Friday, 24th June 2022. Joy Learning Essay Club, improving our writing skills and sharing our thoughts on national issues. Joy Learning, keep learning.
Teacher, the idea of no or confusing road signs can be likened to driving in a dungeon.
Again, for ladies girls, one of our judges for 8 for them.
16 schools in Ashanti are ready to battle for supremacy and the bragging rights as the best school in debate. Can St. Monica's Girls Senior High School defend the title, or will any of the 15 schools including OWAS, Prempeh College, Yasantua Girls Senior High School, TIAMAS, Presby SHTS, Bompata, KNUST SHS, Tepa SHS and the like wrestle it from them? Make a date from Friday 17th June to Friday 15th July 2022 as you get thrilled to fierce and insightful arguments in the Love FM High School debate from senior high schools in Ashanti. Catch the action live on Facebook at LUV 99.5 FM, on radio on Love 99.5 FM, and on Joy Prime and Joy Learning on Monday to Friday at 2 p.m. each day at the Christian Service University College. This event is brought to you by your superstation, Love 99.5 FM, in collaboration with the Ashanti Regional SRC, the Ghana Education Service, and the Conference of Heads of Assisted Secondary Schools, CHAS.
Every day the learning process stops, you die. Think about it.
One thing that I believe is lifelong learning, because that's how we grow as individuals. And there's no better place to learn than at Joy Learning.
Now, Joy Learning is the most preferred channel when it comes to learning. They're the first ever to put out teachers teaching you, taking you through step by step, helping you understand the simple courses and simple things that sometimes you find hard in the classrooms.
I mean, for revision of notes for everything, Joy Learning got you sorted on that.
If there is any channel that is dedicated to the well-being and development and academic performance of students, it's the Joy Learning channel.
The impact is great. Everywhere you go, there's someone who knows Joy Learning.
I love Joy Learning.
Joy Learning channel has become part of our national lexicon when it comes to educational, transformational impartation in this country. And as collaborators, we will make sure that we will continue to do our bit to promote this wonderful experience.
It's the #1 learning channel in Ghana right now. I mean, they have a lot of fantastic, amazing programs tailored towards the betterment of, the knowledge of our students.
Joy Learning, keep on doing what people cannot do. Joy Learning, I give it up to you. Joy Learning, mi jababa mi yiji, maune yirami. Joy Learning, all the best, no challenger.
I encourage you to keep watching Joy Learning, your #1 learning channel.
Joy Learning.
Keep learning.
Welcome back from the break. I know some of you guys are ready to answer questions for me. For tonight, you allow me to in fact continue the main lesson. Okay? So my producer has asked me to inform you that in fact the lines have been activated. So as I give out the question, if you have the answer, you call and then you tell us the answer. Is that okay? You call and tell us. then please, as usual, when you call, okay, and then you want to talk to us, please don't try to listen to yourself from your television set. When you do that, it gives us a negative feedback here. I cannot hear you well, and viewers at other places will not enjoy the show. Is that okay? So when you call, either you reduce the volume of your TV set to the extent that you may not even hear it at all, or just mute it. Mute your TV set so that we can really talk on the phone. Is that okay? So let me give out the numbers. And of course, the numbers have not changed. If you have been watching Joy Learning, the number, you can just save the numbers on your phone. That Joy Learning 1, then Joy Learning what? 2. You know, the numbers are 2. So whenever it is time for you to call and answer questions, you just go to your contact list right there. You click on it and then you are through. Is that okay? All right. So these are the numbers. 03022111705. I repeat, 0302 another 211705. And then the second number, as in the second contact, you just have to change the last number, which is 5, to 6, and you are good to go. Is that okay? So instead of 5, then you make it what? You make it 6, and that's all. My producer will let you in, then you speak with Boga Sam. It is because of you, that is why we are all here. Right, so let me throw the first question, or sort of give you the first question to answer. All right. Okay? Wow. So, first question. Good. So, I have here the question that says or reads, that is the question 1, okay? The invisible or the imaginary straight line around which the earth spins is called, I repeat the question. The invisible or the imaginary straight line around which the earth spins is called A, we have rotation, B, longitude, C, revolution, and then D, we have axis. Is that okay? There's someone on the line. Hello.
Hello, sir. Evening. My name is Martin. I'm talking from Equator line. The answer is D. Yes, sir. The answer is D. Hello? Okay. Hello?
Yeah, so Martin, in fact, you are a shark. You are a shark. The answer is D, axis. That is the invisible or the imaginary straight line around which the earth spins. Okay, let me give out the second question. The second question. Revolution is the spinning of the earth around its own axis. I repeat. Revolution is the spinning of the earth around its own axis. Is it true or false? Is it true or false? Let me add the third question. Okay, I have a caller already. Hello?
Yeah, good evening.
Good evening, how are you?
I'm fine, thank you.
Good. What is the name?
Florencia.
Florencia, speaking from where?
Temu Senior High. Tema.
Tema, that is good.
Yeah.
So, Florencia, I believe you are a geography student.
Yes, sir.
That is excellent. Florencia, what is the answer? Or I should read out the question to you again.
Yes, sir.
Yeah, the question says, revolution is the spinning of the earth around its own axis. True or false? Florencia, what is the answer?
Sir, please, it is false.
It is false. It is false. Florencia, you are correct. You are correct. Should I give you another question?
You are correct. You are correct.
Oh, Florencia, do you know something? I told you that don't listen to yourself on your TV set. Is that okay? All right. So I think we have to, allow Florencia to go after making her input by answering the question. All right. So let's go to the third question. And I read, how many degrees of latitude will the earth spin through within an hour? I repeat, how many degrees of latitude will the earth spin through within an hour? A, we have 5 degrees. B, we have 10 degrees. C, we have 15 degrees. And D, we have 20 degrees. You call and give us the answer. So, yeah, there's a caller on the line. Oh, sorry about that. Please. Yeah, another caller on the line.
Hello.
Hello, how are you?
Yes, sir. Florencia is back again.
Florencia is back again, eh?
Yes.
You see that when you reduce the volume of your TV set, now we can talk and then we can hear each other well. That's very good of you. So, Florencia, I read out the question. How many degrees of latitude will the earth spin through within an hour?
15 degrees.
15 degrees. That is correct, Florencia. That is correct. So, Florencia, don't go away. How about 5 degrees? How many minutes will it take the earth?
5 degrees.
Or that one you don't know?
Yes, I'm working it out.
You're working it out? Okay, work it out and then give me the answer. Is that okay? All right. Okay.
It will be 30 minutes.
It will be 30 minutes. Are you sure? Florencia, let me give you a clue. When I was teaching, I said that it takes the earth every 4 minutes to make a move or an angle of a degree, or say 1 degree. So 1 degree is equivalent to 4 minutes. Is that okay?
Yes.
So if 5 degrees, okay.
So it will be 20 minutes.
It will be 20. That is correct. It will be 20. That is correct. Good. I have another caller on the line. Hello. Hello, Nana.
Hello, sir.
Yeah, Nana, how are you?
I'm fine.
Good. Talking from where?
Bogoso.
Bogoso?
Yes, sir.
That's fine. The name of your school?
St. Augustine Senior High School.
St. Augustine Senior High School. That is good. Nana, listen to this question and then you give us the answer. So you tell the whole world the answer. The earth rotates in an anti-clockwise direction. True or false?
True.
It is true. Nana, you are right. Nana, you are right. But Nana, don't go away. If the earth rotates in an anti-clockwise direction, what name is given to it? Is it retrograde or Retrograde rotation.
Retrograde.
Nana, are you sure? Nana, go back and then come back stronger. Okay? All right, so that question will be hanging. But Nana, you are good. Is that okay? Keep studying hard. Is that okay? Good, Nana. All right, the next question. Yeah, there's a caller on the line. Hello?
Good, Nana.
Hello.
Yeah. What's your name?
On the line. Hello.
Damien.
Good, Nana.
Hello.
Yeah.
Do you know something? As I told you, mute your TV set. Reduce the volume to the barest minimum. Okay? Have you done that? Okay, I'm sure he will come back. So, the question is, the time it takes for a planet or other celestial object to complete one spin around its axis is called its period. I repeat, the time it takes for a planet or other celestial object to complete one spin around its axis is called its period. A, we have revolution. Yeah, there's a caller on the line. Hello?
Hello, sir.
Yeah, what's the name?
Abraham.
Abraham, calling from where?
Tema.
Tema, that is good. The name of your school?
Sir, please, you said.
What is the name of your school?
Tema Secondary School.
Tema Secondary School, that is good. That is good. So, Abi.
Yes, sir.
What is the answer?
Sir, can you read over?
Okay, it reads, the time it takes for a planet or other celestial object to complete one spin around its axis is called its period. We have A, revolution, B, elliptical, C, rotation, and D, evolution. Which one is the answer?
Sir, elliptical.
Elliptical. Are you asking me or you are telling me, Abi?
Sir, it's elliptical.
Are you sure?
Yes.
Abi, think about it well. You should have this answer. You should get it right. Okay?
Also, it's rotation.
It is rotation. It's rotation period. It's as simple as that.
Yes.
Abi, you nearly disgraced me. Should I give you another question?
Yes, sir.
Okay. All right. Abi.
Yes, sir.
Rotation and revolution.
Yes.
Are the two different movements that the Earth, Abi, do you know something? Reduce the volume of your TV set, mute it. Take the remote and mute your TV set. If not, I'll take you off. Good. So I read, Abi.
Yes, sir.
Rotation and revolution are the two different movements that the Earth experiences. Is it true or false?
Say it is true.
It is true. For this one, like if you had it wrong, Charlie, like the way I'll whip you, Charlie, thumbs up, okay?
Okay.
Keep studying hard. Keep studying hard. All right. Now, the next question. All the following are effects of Earth's rotation, except, I repeat, all the following are effects of Earth's rotation except A, day and night. Is it one of the effects? B, we have daily rising and falling of the sea level. Is it true? C, we have dawn and twilight. Then D, we have equinoxes. There's a caller on the line. Hello?
Hello.
Good. How are you?
I'm fine, sir.
Good. Can you speak up a bit? What's your name?
I'm Braco Ebenezer.
Braco Ebenezer.
Yes, please.
Yeah. Speaking from where?
Akokwaso Senior High School.
Akokwaso?
Yes.
That's great. Ebi. Oh, no, Eben, rather. Ebenezer. Eben.
Yes.
Which one is the answer?
Equinoxes.
Equinoxes. You are correct. Thumbs up. You are correct. Thumbs up. Should I give you another question?
Yes, please.
Okay. Hey, man, students, Eben.
Yes.
The rate of Earth's rotation is expressed in degrees. The rate of Earth's rotation is expressed in degrees. True or false?
True.
It is true. It is true. For this one, like if you get it wrong, Charlie? Thumbs up. Amen. Keep studying hard, okay?
Yes, sir.
All right. Let me throw this question quickly so that I go back to the lesson to continue. If not, hey, already there's a caller on the line. Hello?
Yeah, hello?
Yeah, what's your name?
I'm Maxwell from Dunkanofin.
Dunkanofin?
Yeah.
I guess you have lots of gold there, right?
You said...
Okay, that is just by the way. Let's go straight to the question. Are you ready?
Yes, I'm ready.
Okay. Take your remote and then mute your TV set.
Yes, I'm ready.
Have you done that? Have you done that?
Yes.
Good. Which of the following planets has the shortest orbit round the sun? I repeat. Which of the following planets has the shortest orbit around the sun? A, we have Mercury. B, Earth. C, Neptune. D, Mars. Which one is the answer?
A, Mercury.
It is Mercury. It is Mercury. This one very simple. Is that okay? Okay. Okay, Charlie. What's your name of your school? Okay. All right. So before going to the next question, going back to the main lesson, let me read out this question. The speed of Earth's rotation varies with latitudes. The speed of Earth's rotation varies with latitudes. True or false? Then you call and tell us the answer. So quickly, let's go back to the main lesson. All right, so we talked about dawn and twilight as being probably the last effect of earthward rotation. Good. So here we are on revolution of the earth. So once we have more time, there's a caller on the line. Hello?
Hello?
Hello? Yeah, how are you?
I'm fine.
May I know your name?
I'm Harrison from Bishop Herman College.
Harrison from Esojamain College.
Hey, Bishop Herman College.
Oh, okay. Okay. Harrison, tell the whole world the answer. The speed of Earth's rotation varies with latitudes. True or false?
It's false.
It's false. Are you sure?
Oh.
Harrison, when I was teaching, what did I say about the speed at the poles and then the speed at the equator? Okay. So, Nana is on the line. Hello, Nana.
Hello, sir.
Yeah, how are you?
I'm fine.
Nana, I know you know the answer, but let me still read it out. Nana, the speed of Earth's rotation varies with latitudes. True or false?
False.
Oh, Nana, are you sure? Nana?
Yes.
Are you sure?
Yes, sir.
Think about it, of course. If it is not false, it is what? Sorry, then it is true. It is true. The speed of Earth's rotation, it varies with latitudes. When I was teaching, I did tell you that at the poles, even at the poles, it is what is zero. When you are exactly at the pole, it is zero. The speed is what is zero. But as you descend, or the latitude decreases, okay, towards the equator, we have the speed what increasing. So,
okay, sir.
Hello, Angie.
Hello.
Yeah, Angie, how are you?
Fine, sir.
Good, Angie. Speak up a bit, okay? Because the whole world is listening to you. Yeah. What's the name of your school? Come again. Bremai, okay. I'm reading out the question, Angie. The rotation of the Earth on its axis results in all of the following, except I repeat, the rotation of the Earth on its axis results in all of the following except A. Time differences between the meridians. B. The seasons. C. Day and night. And then D. The daily rise and fall of the tides. Angie, which one is the answer? It is what? The seasons. You are right, Angie. You are right. Thumbs up. Thumbs up. Okay? This is the season, because when we were learning, we got to know that time difference is one of the effects of rotation. Day and night was even the first point. Then the daily rise and fall of the tides was also another word point. That is good. That is good. Keep studying hard. Okay? All right. Question 12. All places on earth experience 12 hours of darkness each day. True or false? All places on earth experience 12 hours of darkness each day. True or false? So you call and tell us the answer. So we are on revolution of the earth. Now, when we talk of revolution of the earth, what is it about? We did establish that there are two main different movements that the earth experiences, of which I've even asked one question on it and then the caller had it. That is rotation and revolution. Now, we are done with the rotation. We are saying revolution of the earth is what? The movement of the earth on its orbit around the sun. Is that okay? So, in this case, we are talking of the earth rotating in the first place. And at the same time, this earth going around the sun. Okay? Movement of the earth on its orbit around the sun. And when we talk of the orbit, what do we mean? The very path on which the planets travel around the sun is what we call what? Orbit. Or if you can say the way on which the planet would move around the sun is what we call what? Orbit. Is that okay? Now, yes, so we even have it. So the orbit is the path along which the earth revolves around the sun. That is said already. This orbit is elliptical or oval in shape. And it takes the earth a full year. That is 365 1/4 days for one complete revolution around the sun. Is that okay? So, before the earth, which is rotating, and now going around the sun, can make a complete revolution, it takes it what? 365 1/4 days. But then when it comes to rotation, as in complete spin, it takes the earth what? 24 hours. And then that is complete. Okay? But revolution, 365 1/4 days. Then it makes a complete year. So that is what we term as what? A year. Earth year. Okay? Now, this extra quarter day is responsible for our leap year. When we talk of a leap year, what is the meaning? You know, have you forgotten that sometimes when we are writing the dates and February, sometimes we record the last day to be what? 28th February. And once a while to record what? 29th. Have you now remembered? So sometimes we have 28 days for February, and sometimes we have about 29 days for February. So what we are saying is that this extra quarter day is responsible for our leap year every 4 good years. Don't forget that I said it takes the Earth 365 1/4 days before able to go round the sun completely. Okay? The 1/4 day, that is 1/4. So it's just like 1. Then dividing it into what? Into 4. When you bring all these 4 divisions together, you get a whole. You have 1. So if you have an orange, okay, you divide it into 4. You bring all these 4 divisions together, you get 1. So it is such that every 4 good years, as in 4 years interval, okay, we have this quarter day, 4 times coming together to make what? A full day. And so that particular year, February will not have what? 28 days, but rather it will have what? 29 days. And so that year we have 366 days instead of 365 1/4 days, making the year. And so that year is what we term as what? A leap year. That is the 366 days, making a year. That is a leap year. So, whenever you want to know whether a particular year is a leap year or not, just take your calculator. Let's say we are now in 2022. Is that okay? Divide 2022 by 4. When you divide it by 4, then you get fractions. Then it tells you that it is not a leap year. We are still adding the quarter days. Is that okay? But when you take a year like 2024, then you divide it by what? 4, you get a whole number. When you get a whole number, then it tells you that is as in the answer without what? Fractions. Then it tells you that that year is what? Is a leap year. Is that okay? Now let's make progress. The Earth revolves in an anti-clockwise direction. We have established that already. Okay? And that is from west to east. That one too, I've told you. It revolves around, as in the Earth, it revolves around the sun at about 108,000 kilometers. Is that okay? Which is equivalent to 67,000 miles per hour. So 107,000, it's an average, figure. Is that okay? 107,000, 108,000, they are all correct. Averagely. Okay? Which is equivalent to 67,000 miles per hour. As in, the speed that the Earth goes around the sun. It is not easy. Within a space of 1 hour, the Earth might have gone around the sun. And that distance alone is what? 108,000 kilometers. And so if at the Accra-Kumasi Highway, drivers are advised to go 120 kilometers per hour. So just ask yourself, if the driver starts from Accra here and then on 120 kilometers per hour speed, where will the driver get you? Then you can imagine this one, 108. So there's a very, top speed. Is that okay? Now, as we find ourselves on the Earth, we don't feel or notice this speed because everything around us is moving at the same rate. Hey, I want to believe that I've not given someone an apple here. I repeat, as we find ourselves on the Earth, we don't feel or notice this speed because everything around us is moving at the same rate. The same rate of speed that the Earth is rotating and revolving. Once we are on the surface of the Earth and being held to the surface by the force of gravity, we are also moving at the same rate. And so, as you see me on your screen, you don't see me rotating, going around, because you yourself, once I go, you also go. We are all on the surface of the earth. Okay, let me not talk too much here. When it gets a particular time, then I throw more light on this. Is that okay? A planet's period of revolution is called a year on that planet. So what I mean by this statement is that when we take our Earth, our planet, okay, we know that it takes it 365 1/4 days, or say 366 days being a leap year, to make a complete year. But when we take that of Venus, Venus will not be 366 or say 365 1/4 days. It will take it around 288 days. Is that okay? And so on planet Venus, that's 288 Earth days that it takes the planet Venus to complete or say go round the sun. That is Venus 1 year. So assuming you are on planet Venus, your year will not be 365 1/4 days or say 366 days, but it will be 288 days. I hope that is clear. Good. So now, Mercury and Venus are approximately. Oh, I must correct this. Sorry. You see, Mercury and Venus are approximately. It takes them 88 and 225 Earth days. Sorry. So when it comes to Mercury, it takes it 88 Earth days to be able to revolve round the sun, and that of the Venus 225 Earth days to revolve once around the sun respectively. Please, let's take note. That is 225 for the Venus and 88 for the Mercury. Good. Now, comparing these two planets to that of the Earth, more days are needed for the Earth to complete its revolution due to its average distance of 148.8 million kilometers away from the sun. Is that okay? I believe even this one I talked about it. If we should use the athletes, those who run in the tracks during sporting events, like during interco and stuff, okay? Whoever picks the last track, if say the tracks are up to 6, whoever picks the track 6 has a longer distance to go round. But whoever picks the track 1, the distance is shorter. And so if it takes the Venus 225 days, so let's assume that Venus is on track 2, okay? And then Earth is on track 3. It means that the Earth has a longer distance to cover. So in other words, it will take more Earth days for it to be able to go around the sun. But then it will take the Venus 225 days. So please take note about that. Yeah, let me repeat the question. Probably you guys did not get a question. I was saying that all places on Earth experience 12 hours of darkness each day. Is it true or false? Then let me add the next question. Now, if a planet spins in a clockwise direction, just like Venus, it is said to have a rotation. I remember asking this question along. One person answering a different one. And then that was it. It has come back. If a planet spins in a clockwise direction, just like Venus, it is said to have a rotation. Clockwise. Is it prograde rotation, retrograde rotation, antrograde, or postgrade? You call and tell the whole world the answer. Maybe let me add the question 14. So we have question 12, 13, and 14. So question 14. The third planet in order of nearness to the sun is the Earth. This one. Hey, as for this one, Whoever tries to answer and does not get it right. The third planet in order of nearness to the sun is the Earth. True or false? That is question 14. So you call, they tell us that once again the lines are 0302, another 211705, or 0302, another 211706. So back to our lesson. Now, good. We have two terminologies here. One, we have what we call aphelion. And the second one, we have perihelion. Sorry. Is that okay? Now, here we are saying the distance between the Earth and the sun changes every day. You know, I've already given you a distance of 148,800,000 kilometers, or say approximately 149 million kilometers. Is that okay? But then I'm saying here again that this distance, it keeps what changing. In fact, every day, because the orbit is an ellipse or oval. And already you know the orbit. That is the path on which the planet travels. Is that okay? And we are saying the distance is not the same throughout because of this particular shape of the orbit, which is what? Elliptical or oval in shape, like the shape of an egg. It is not completely what? Circular. Good. So, when the Earth is farther away from the sun than the average distance of 148,800,000 kilometers, it is said to be aphelion. It is said to be what? Aphelion. Whereas perihelion is when the Earth is closer to the sun than the average what? Distance. So let me give you a clue so that you can remember. When the distance is rather farther away, when the distance is farther away, the word, as in the spelling of the word, is rather shorter. So the farther the distance, the shorter the word. And then when the distance is shorter, the word is what? Is long. As in how it is, the number of letters are many, so the word is what? Is long. So aphelion, farther distance. Perihelion, shorter what? Distance. Is that okay? So let me demonstrate that quickly here for you to see. Let's take this to be our sun. Is that okay? This is our sun shining. Now, we have the orbit in an elliptical shape. In other words, in oval what? Shape. Good. Like an egg. So all that we are trying to say is that as the Earth keeps revolving, this is the Earth revolving around the sun. Okay? So we have the Earth. Sorry. So let me draw my orbit again. Good. So we have the Earth, okay, or the axis. The Earth is looking at position A. So let me draw the distance using arrow. Okay. Look at, let me rather bring the A here. Looking at distance A. Okay. Then distance B. So let's, another point, the Earth is here. Then let's look at distance B. So here is B. When you check line A, or say distance A, let's use this one. When you check distance A, or you compare distance A with distance what? B, you will see that B is what? Is shorter. So it tells you that at this point, the distance between the sun and the earth, which is 148,800,000 kilometers, will not get it. It will what? It will reduce. Is that okay? Good. But then, when we take that of A, it will also be more than the 148,800,000 kilometers. So when the distance is shorter, the shorter the distance, the longer the word. That is what? Perihelion. Perihelion. Is that okay? Then, when the distance is longer, the longer the distance, the longer the distance, the shorter the word. So we have aphelion. Is that okay? So then, one of the effects of revolution of the earth is what? We can talk of what? Aphelion and what? Perihelion. Is that okay? Good. Now, okay, we have the effects here. So the following are some of the effects of Earth rotation. One, we have the varying length of day and night at different times of the year. You see, sometimes we have a longer day and shorter night. What causes that? It is the revolution of the Earth. Is that okay? Then also changes in the altitude of the midday sun at different times of the year. The altitude, okay, is not the same throughout the year. Good. Then changes in season. Yeah, changes in season. Very, very key. Very, very key. Then we also have marking of a year. Marking of a year. So, if you remember, I told you that as the earth revolves around the sun, okay, it takes it 365 1/4 days or 366 days to make a complete revolution. And that makes a year. And so if that is the case, then it means that it is revolution of the earth that makes what? A year. That helps us to know that, oh, a year that started from somewhere has what? Has ended. Is that okay? Do we have more? Okay. So, this varying length of day and night at different times of the year, very, very interesting. In fact, unfortunately, we don't have much time for me to explain this into details for you. But, fast forward. You may heard of equinox when I was reading some of the questions. When we talk of the equinox, it is at a point in time whereby the length of day and the length of night at opposite sides or surfaces of the earth is what? Equal. The length of day and length of night are these lengths are what? Are equal. So 12 hours, 12 hours. Is that okay? Then solstice, we have different lengths of day and what? Night. Is that okay? I want to believe that you have really enjoyed this particular live show. I want to encourage you to keep studying. The day that learning stops, you may die. As our big man, Nathaniel Arthur Riley, said or has been saying when the advert is being run. So keep learning. Don't stop learning. Enjoy learning, keep learning. Once again, the name, the training name is Bogasam. And I must say a special hi to my assistant head mistress, Madam Lydia Bante of Achimota School, who celebrated her birthday just yesterday. Mommy, belated birthday. I thank you all for watching, and all geographers in Ghana, Ghana Geographers Association, I salute you. Thank you so much for the contributions that you keep making before and after the show. I call it done.
Hello kids! The time to prove that you're the best and biggest kid chef in Ghana and beyond is here again. Join Season 2 of the Big Chef reality show on Joy Prime to exhibit your culinary skills and win amazing